Hello, today is all about refactoring. This is part 4 of my Conway's Game of Life series. If you haven't watched the previous 3 videos, you can find the links in the description. So let's get down to it. Turns out that I was looking at this piece of code, and despite you could say it's simple enough to understand, I think that there are a couple of things that could make a little bit cleaner, and maybe it's worth to give it some love. So let's take a look at what we can do. So the idea that I have in mind is that instead of placing the code that mixes the color inside this evolve module, maybe it would be interesting to extract or to create some color class that could allow us to not only represent a color in our code, but also be able to manipulate that color in a simpler and more readable way. So let's see how we could go about that. First of all, something interesting to remember is that at this point, maybe it could be easier to do everything that we will do using TypeScript, because TypeScript would warn us about what things we have to change on each step of our refactor process, but this can be done perfectly with just JavaScript. Also, what is refactoring, for those of you who don't know? So refactoring is the practice of changing your code without changing the functionality, and that helps with keeping a code base clean, maintainable, and in a shape that allows ultimately to keep on working at a constant pace instead of the velocity going down and down and down until you cannot do anything else without introducing bugs or those kind of things. And something very important that we will see is that the idea of refactoring is to do it step by step in very little steps and test that everything keeps on working with every step. So in this case, it will be very easy to test that everything is working, because it's just taking a look at the result in the browser. It's just taking a quick look and we can tell if everything keeps on working. But in many other cases, what you usually do is use testing tool that runs tests whenever you like, and you can check that everything keeps on working. So with all these clarifications, let's get down into it. Okay, so the first step I will go about is to replace these representations with my new potential class. So what I want to do is, instead of representing the colors with just plain arrays, I want to create instances of a color class. And bear in mind that I don't yet have the class, but still I can pretend that I have it just to start defining how I want my class to work. So let's just change this. And here is with where TypeScript would definitely help a lot, because it would complain about color not existing and so on. It will be like probably visually easier to detect where I have to fix things, but doesn't matter. Obviously, what I can do is always start the app. Let's wait for it. There we go. Open a browser, and it should not work at all. But let's wait until this loads. All right, so uncaught reference error, color is not defined. Obviously, it's not defined. So let's reload. So here we have the error. This is sort of what TypeScript would do if we had it there. In this case, given that we're not using TypeScript, we have to run the app to get to see the errors. And I think this is easier than having that, than trying to look around to see what things we have to change. We can just run the app, check the issue, and fix it right away. So color is not defined. Let's just come here and create color.js. So what I will do here is export class color, and this should be enough. I mean, that's the only thing I need for color to be defined. And I have to obviously import color from, where is it? No, one level above, color.js. There we go. And I think that this should at least change the error we're getting. So if I reload, no, okay, this is another pattern. Let me use the pattern that I was just editing. Gosper. There we go. Reload. All right, now we get a lot of errors. Object is not iterable, and this issue is happening at render.js line 21. So let's go there. Render line 21. Okay, so this makes sense. The issue is that at state row column, we used to have an array with the colors red, green, and blue. The problem is that this is not an array anymore. This is a class, and we have to get the red, green, and blue values from the class. The issue is that our class doesn't yet have a way, or is not yet storing the red, the green, and blue values. So let's fix that first. So if we check the pattern, what we're doing is in the constructor, or when we create a class, we're passing the red, green, and blue values. So here we have to store them. And to do that, we can do constructor red, green, blue. And I will do this red equals red, this green equals green, this blue equals blue, and this should be enough, at least to store them, but I'm still getting the same error because I'm trying to destructure a class. There could be a way of using this syntax with a class. I should provide an iterator, but probably it's not necessary. What we can do is simply the following. We could just say that this is color, and here we can do color red, color green, and color blue. And if I save this, hopefully, okay, this gives a different type of issue. It's more visual. Clearly, this is not completely working. It seems that render works up to some point, but then when the game tries to evolve, something is failing. So maybe we can commit the changes so far. So we have our class, we have a change in main, which is using Gosper, we can commit that, no problem. We have the changes in render, and we have the changes in Gosper, in which we are using the color class that we created. So here uses color class. I guess that's fine. So now we have to fix the evolve method and see how we have to adapt it to use the new class. But the important thing here is that I'm going step by step, right? I just created the class, now fixed or adapted the render method, and now I will focus on evolve. Okay, the next step is to take a look at what's going on with evolve, each of the functions one by one. The first one is evolve, and well, we iterate over all the matrix. There's nothing strange here. So let's take a look at calculate new self value. We get the live neighbors, that's fine. In this case, we just return the same thing as we had before. That's okay. And I guess here is where we are gonna start changing things. So, okay, so this is the piece of code that made me originally think of extracting this new color class. You could say it's readable enough. You have colors, you reduce them, you start by 0, 0, 0, and you sum each of the values. But if you're someone looking at this code for the first time, maybe you can start asking, okay, what is 0, what is 1, what is 2? Why we have to sum each of them one by one? What's the thing that we're doing here? So here's where having a color class can help express in a better way what we're trying to do. And that is very valuable. Code that expresses its intent by itself is something that you definitely want to aim for. So let's see what we can do. I think that first of all, what I'm going to do is extract, or not extract, move this colourMix function into the color class. So if I go to the color class, right now it's very simple, but what I can do is just copy this, paste it here, and I will have to remove the function because we're inside the class here, and I will declare this method as static. And also let me just call it mix, and I'm declaring it as static because this is a method that will belong to the class and not to any instance, because I want to create a new color from using this mix method here. So it doesn't make sense for it to belong to an instant. It has to belong to the class itself and not make me instantiate the class to be able to use it. It will make more sense once I go ahead and use it. So here we will receive many colors. It's the same code for the time being, but yes, it's exactly the same code. So here, what I will do is remove this function, and instead of using the function itself, I will use color.mix, and it will mix the live neighbors. And here I will have to fix this because VS Code doesn't automatically add the JS there. I don't really know why. Someone wants to leave in the comments why, that would be great. So if I save this, I will probably see no actual change, I guess, but at least I should still see the same issue going on. So if I reload, yeah, everything looks more or less the same. Let me just open the console and make sure we're not getting an error in the console. Okay, that's great. So let me commit this, and we can say moves the mix method into color, into the color class. That's great. So another benefit of doing this is that now I have all the color related code inside the class. So I can, if I'm not mistaken, yes, I can actually close this file and focus on this file. Okay, so the next step is to change this so it makes a little bit more sense. So I think that if every color is an instance of the color class, what we can do is change all this to actually use that syntax. Actually, if I don't change it, that's one of the reasons why we're getting this behavior. It's not working because now these things are instances of the color class and we are treating them as plain arrays. So let's go ahead and do that. This should be new color 0, 0, 0. And now previous and current will be instances of color. So what we can do is, well, let's start from the top. Let's say I want to be able to do something like the following. Prev dot sum current, and I will rename this previous. If I'm using the complete word here, I think it makes sense to use the complete word here as well. So this is what I want to do. Previous sum current. Obviously sum doesn't work. I mean, it's not implemented. If I save this, it will explode. Sum is not a function, obviously. So let's create that function. Sum. So this will be, it will receive another color and it should return new color, and the red component should be this.r plus other.r, and then the green, this.green or g plus other.g, and this dot, whoops, this should be a comma, this dot b plus other.b, and this, well, I was expecting prettier to maybe format it a little bit. Okay, prettier likes it that way. I will leave it like that. So we're creating a new color where we have the red component, the green component, and the blue component. And actually, I don't like how this looks. Let's do const red this.r plus other.r, and we can do rgb and now we can do rgb. I think this looks a little bit cleaner. It's just coding style. So this should work, but now we are trying to do a max between all the elements of sum, but this doesn't make sense anymore. Sum used to be an array, but now it's not an array anymore, so we cannot destructure it, at least without having to write some extra code, I think it doesn't make sense at this moment. So we can change this to something else. But before doing that, let me just reload. Spread syntax require iterable symbol iterator. Okay, so yeah, exactly. We should implement this. I'm not gonna do that now because I think it exceeds the scope of this video. But this is really simple. I have to get the max between some R, some G, and some B. Far reload. Okay, some map is not a function, so we're almost there, but we have to finish yet. So here what we're doing is like normalizing the sum into a number between 0 and 255. I think that we can do the following. Normalize, and I want to pass sum. Actually, no, it's not even necessary. So we just normalize it. How we're gonna do that? We write the method here, normalize, and it should return new color with. Well, we can do something similar to what we did here. Let's return RGB, and we can calculate them here. R equals this R divided by, we need the max. So we can move this code here. Yes, we can move this. It actually looks better. So we calculate the max on, not sum, on this, because we're gonna call sum.normalize. So in that case, this will be sum. Let me just make that clear. So we calculate the sum, and then on that sum object, we're gonna call normalize. So this will point to this object. So we get the red, green, and blue, and divide by max and multiply by 255. And we're gonna do the same with green and with blue. And there we go. And to finish, we just return a new color as always. I mean, we could modify the values, but whenever we call a method, I'm choosing to return a new instance, not to modify the instance I'm calling the method on. I think that prevents a lot of nasty bugs that can appear. So I guess this should be it. Let's see. Reload. Something's still not working. Let's see. Do we have errors? No. We calculate the mix. Okay, we start with 0, 0, 0. We sum the current. Sum should return a new color with. That's fine. That looks good. Okay. All right. Let's take a look at evolve. So here, calculate. Okay. Okay. Color mix. Looks as if it should be working. this is the issue. G, B, G, B, reload, and there we go. Now it works as expected. And again, in this case, it's really easy to see that everything is working as expected. So it's just a matter of reloading and checking that the gliders are created with this color. So I'm not using any type of automated testing, but in other cases where things are not as easy to check, it's probably worth it to have just a command that you run, and the command tests everything for you instead of having to check things manually. So let's commit this. The message could be extracts some unnormalized functions to make the code cleaner. All right, so this wraps this new video up. So just to recap, what we did was work on creating a color class that holds not only the data of the color, but also methods that allow us to manipulate things in a more expressive way, especially here where we can say that mix, like this function, mix receives a couple of colors and then reduces them by starting with a color that is black, and then on each step of the reduce we just get the previous and sum the current, and finally return the normalized version of sum. I think this code looks much better than what we had before, and also is better organized, because before we had this mix function just here with other methods that did things that were pretty different. For example, checking how many neighbors we had, or getting the actual neighbors and so on. I think it's much better to have the code for handling colors all in the same place. We could keep on repeating this process probably with some of the evolve functions, maybe with code to move through the grid, but I will leave it here for now. So again, thanks for watching and see you next time.